Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will explore generative adversarial network. So let's get started. So first of all, what is generative adversarial network, right? So it is a type of neural network which use to generate new images which is similar to training set, right? So as I say, we need to generate new images which are similar to training set. So you can recall our previous video in which we had understand variational autoencoder, right? So in variational autoencoder, we also generating new images which is similar to our training set, right? But generative adversarial network is an improved version, we can say, or doing far better job in creating realistic images than the variational autoencoder. There is one point, like generative adversarial network is hard to train compared to variational autoencoder, but it's done a very good job to generate new images, right? So let's understand how this network works. So first of all, let me provide a brief overview that how this network works, then we will go in depth. Okay. So first of all, in generative adversarial network, we have two neural network. Okay. One is a generator and second is discriminator. If I say in simple terms, your discriminator is the classifier. Okay, so I can write here, let's say classifier. Okay, and the task of generator is creating a new images which is similar to our real data. Okay, so now generator will generate few images and we will extract few images from a real image, okay, which is our data set, and we will pass these two images to this discriminator model. Okay, and this discriminator model will try to classify these two batch of images which is generated and other is real. If this discriminator are able to classify these two images very well, that means generator is not able to create a similar images related to our training point, right? If these two images are same, then the discriminator will not able to classify these two images perfectly, right? So let's say this is y is equal to 0 and this is y is equal to 1, and this classifier can predict correctly, that means these two images are far away from each other, right? Hence the task of generator is creating a new images which is very similar to real image. Hence discriminator loss will be maximized, right? If discriminator is not able to classify, then that loss will be increased, right? And discriminator will try to classify it and it will try to minimize the loss. Okay, so now let's understand how the whole process work and how we will train this model, right? So let me erase this first. Okay, so for the understanding, let's say our task is to generate new, let's say mnist. Okay, we need to mnist digit, we need to generate new mnist digit. So our real data would be mnist dataset. Okay, so first of all, let's say generator. So generator can be any kind of neural network or any model, right? So if you are dealing with the images, you can define convolutional neural network, or you can define artificial neural network which contains the dense layer and fully connected layer, right? Or if your data is like that, then you can use RNN as well. Okay, there is no restriction that generator should be uh, any kind of fixed neural network, right? You can use any kind of neural network there as much as it is fulfilling our needs. Okay, and same the discriminator also can be CNN or ANN or RNN, and at the last it will classify. Okay, so these two parts are clear. Now let's say what would be the input to this generator. Okay, so as an input we will pass a noise of any dimension of noise. Let's say my MNIST dataset has 784 dimension, right? So we need to create 784 dimension images, and here we will pass something, let's say 100 cos 1, the noise, and then we will generate the image of the 784 dimension. Okay, so we are not going in depth of generator architecture because it can be any kind of neural network, right? So we are passing here noise, so it is not like any kind of noise, but we will use random normal distribution. Okay, let me write normal distribution. Okay, so why we are using normal distribution here? Because research says when we are using the noise from the random normal distribution or Gaussian distribution, it performs very well. Okay, so now we know as an input we will pass any random normal noise. Okay, and now this neural network will create images or generate some images, right? So let's say I am using batch size is equal to 64. Okay, so I have now 64 images here, right? So it could be, let's say 64 into 28 cross 28, right? Simple. And we can treat it as a CNN. If you are treating it as a CNN, then 28 cross 28. Otherwise it will be 64 into the multiplication of these two, right? If you are dealing with artificial neural network there. Okay, so now we have 64 generated images here, and now same from the real data or our training data. So let me write here, it is our training data. Okay, so from training point we will randomly select 64 images, which is our batch size. Okay, so now we have two sets of images. First is generated and second is selected from the training point. Okay, so now for these images I will provide y is equal to 0 as a label, and here I will provide as a label y is equal to 1. Okay, so now we have total data set of 128 images of two class 0 and 1. Okay, now this data set or sub data set, right, which is basically a batch size. So this data set will be passed to discriminator, and discriminator will try to classify these two sets of images. Okay, so as we know, for the classification we can use log loss. Okay, or you can say binary cross entropy. Binary cross entropy, right? Okay, so let's say if this is also some kind of neural network, right? If this neural network is able to classify these two sets y is equal to 0 and y is equal to 1 very well, that means loss is minimized here. Okay, or you can say we are getting less loss. Okay, that means the image which is generated by the generator are not similar to the training point, right? Because discriminator is able to distinguish these two class very easily, right? That means generator is not doing a good job to generate new images. Okay, so the discriminator task is to minimize the loss, right? Okay, but what generator wants? Generator needs to create a image which are very similar to training point, hence the discriminator loss will be maximized, right? Discriminator tries to minimize the loss and generator will try to maximize the loss, right? If discriminator is not able to classify these two sets of images, that means generator is creating similar images, right, that our model is not able to distinguish. Okay, so this is the case. So now the point is, we understand the discriminator wants to minimize the binary cross entropy and generator wants to maximize that, but how we can train this model, right? So for now we will train one model at a time. Okay, so for first let's say for first batch or first few batch. Okay, what we will do, sorry, let me here. Okay, so first we will train discriminator for few steps, or you can say for few batches. Okay, so let's say we will freeze the weights of generator. Okay, so when we train the discriminator, we will not update the weights of generator. So based on this y is equal to 0, y is equal to 1, this set, we will train a generator, right? So freeze the weight of generator and update weights of discriminator. Okay, after few steps we will do same term, like freeze the weight of discriminator. Okay, and update generator, right? But how? Like for generate discriminator, we know we will pass y is equal to 0, y is equal to 1 and minimize the loss. But how we will maximize the loss while we are updating the weights of generator? Okay, so while we train the generator, what we will do, like generator will create, because we had trained, or you can say pre-trained, okay, the discriminator for few steps. We had seen, like first we will train the discriminator for few steps. So discriminator knows how real images look like and how the random images looks like. Okay, so discriminator learns how to classify. So now here, while we need to train generator, we will pass y is equal to 1, not 0. Okay, so if we pass y is equal to 1 for generated images, the discriminator will predict y height is equal to 0, right? Because discriminator learns that if image looks like the MNIST dataset, then predict 1, otherwise predict 0. Okay, but here what we are doing, we are changing the label of the fake images or generated images is equal to 1. And if discriminator predict 0 for these images, that means images are not similar and this loss will be maximized, right? And if discriminator is not able to distinguish and predict y hat is equal to 1, that means our loss will be minimized, right, at that time. Because if discriminator is not able to predict very well, then generator needs to the loss of generator is minimized, right, in that case. So while we predict the generator, we will provide y is equal to 1 and generator will try to, discriminator will try to predict y is equal to 0 if they are not similar, and otherwise if we predict the y is equal to 1, that means generator is doing good job, right? So this is the alternate training procedure of generator or generative adversarial network, right? So let's see the use case of this generative adversarial network. Okay, so first use case, as we know, image generation, right? We can generate the images. Let's say we can generate MNIST images, we can generate some fashion images, right, and any kind of images. The second thing is we can use it as a data augmentation, right? So some of the application requires a large amount of data, right, and we do not have that. So one thing we can do, we can create new data using this generative adversarial network, but it will be a very costly approach, right? Because if you see, the first of all, the training this generative adversarial network is hard. Okay, and second thing, to train one neural network or one model, you will train this generative adversarial network which will create the new data set only, right? So it would be very costly approach for the data augmentation, right? And third thing is super resolution. Okay, so in which what we are doing, we will pass a low resolution image and that will be converted into high resolution image. Okay, so if you see this application super resolution, in that case here we will not pass the random noise, but we will pass a low resolution image, and here there would be high resolution images are there. and then we will compare low resolution and high resolution images, and based on that this generative adversarial network will be trained, right? So this is all about generative adversarial network, right? If you have any question or query, you can ask in the comment section, we can discuss there. And if you like my video, please press the like button and subscribe my channel. Thank you.